All right, guys, I want to pick up where we left off yesterday. Shouldn't be too much that we have to finish here in this section. Last class I had a little bit of time at the end. But yesterday we were finishing up in the bell rang what supplementary angles were. Just to rehash that definition, supplementary is simply two angles whose measure have a sum of 180. Okay? It says nothing up there about how those two angles have to be orientated to one another, meaning they're positioned to one another. They don't have to be touching. They could be. They don't have to be adjacent. They could be. They don't have to be overlapping. They could be. Okay? Or they could be completely separate. All right? They could be on different pages. They could be on different planes. There's no requirement for how they position themselves. Okay? That's going to be important that we understand that for another vocabulary word that we learn here in a little bit. Okay? So we ended with that. Okay? I think I told you also that, like, if you're going to, because complementary was that they have 90, supplementaries they have 180. Alphabetically, C comes before S. Numerically, 90 comes before 180. So if we respectively associate those, C goes to 90 and S goes to 180, that might be a way for you to remember which one is which. Okay? Eventually, we'll use it so much that it'll be common knowledge. Okay? This is maybe, if you see the headline that I had on that slide, this is probably one of the most important ideas you need to realize for this course. Okay? There's not a lot that we have to do here, but it's something that we have to make sure that we are understanding of and comfortable with kind of approaching our problems this way. And when we're done talking about this, we'll talk about how authors of questions will kind of play off of this idea. They'll kind of exploit this idea with students. So I want to make sure we understand this. First of all, it says there are some relationships that you can assume to be true from a diagram. Some relationships that you can look at a picture and know a fact from the picture. Okay? There's a very, 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 very small list of things that you can assume from a picture. The first three bullets there are pretty much, there's maybe a few others that will add to this throughout the year. But this list is a very short list of things that we can look at a picture and we can make an argument or a fact about the picture based on the way it looks. Okay? One of those is that angles are adjacent. Okay? And the way we can add things to this list is basically off of definitions. The definition for angles are adjacent is basically a recognition thing. Do they have the same vertex? Do they share common side? Are there no points in common? That's a visual understanding of what adjacency means. Does that make sense? Okay, you're going to go through that list of relationships and see if those exist for the angles you're dealing with, and then adjacent or not. Okay. The next one says angles are adjacent and supplementary. That's one that we can look at a picture and talk about. Okay, and argue that to be true. And then the last one, angles are vertical angles. That is based off the way vertical angles are defined. They say that they are when two sides of an angle end up being opposite rays for a second angle, then those two angles are vertical. That is a structure that allows us to look at a picture and determine whether that's occurring or not. Okay. The other things that are up there, the next three bullets, are all about kind of like measurement. Anything that is referring to a measurement, equality, or congruence is something that you cannot tell by looking at a picture. Okay? And just to maybe prove that point to you, let me real quick, while you're writing those things down, I'll open something up here and try to prove that point to you. What's that? Oh, I'm sorry. You're going to have to wait till this gets... There we go. All right, so here's the bottom statement, where it says angles or segments are congruent. You cannot determine that information from a picture. Angle is a right angle. Can't determine that from a picture. That's the one we're going to talk about here in a moment. And angles are complementary. That kind of piggybacks off the idea that there's a right angle. So I'm going to look at this picture here. And if I give you that right there, I draw that picture in front of you, okay? It looks like a 90-degree angle. Would you guys agree with that? Okay. Now, if I were to actually put my protractor on there, okay, which GeoGebra has a built-in protractor that is measuring these angles, and it will measure it out to, if I want to go 15 decimal places, it'll be that precise. And if I ask what the measurement of that angle is that a right angle? Angle, it's got to be 90 degrees, right? That angle is bigger than 90 degrees. That's an obtuse angle. All right? Your eyes are going to mislead you. Your eyes are not precise enough, okay, to tell measurements, especially very minute differences in measurements like 90 and 90.13, okay? So kind of keep that in mind. If it looks like something's a right angle, it is not going to be a right angle, or we're not going to assume it to be a right angle until there is notation that tells me it's a right angle. Now that would be 90 degrees. Does that make sense? Or I could view that from that picture and make the argument that it's going to be 90 degrees. So that being said, I want to draw a little picture over here real quick and ask you a few questions. All right, so if I've got, let's just call this point A, B, C, D, E, and F. And I ask you this question. Is the measure, let's not go measure, let's just go angle. Let's go angle EDB. Angle EDB. Is it congruent to angle DBC? So right now we're looking at that green angle, that's EBD. Oh, I messed that up. Should be stroke by stroke. EBD. Sorry about that. And then DBC. Are those two angles congruent? Hunter, your head shaking no. Why? You're right. Right? Okay, so you're saying if I add them together, we don't know if that totals 90 degrees. Okay? So that I would agree with. We don't know that. But if we did know it was 90 degrees, or maybe if we knew it was 100 degrees or whatever, are those two, so if EBC, everybody see EBC? If that was 90 degrees, if I told you that was 90 degrees, could you tell me that you know by one that the green one's 45 and the yellow one's 45? Could you tell that? No, because that green one might be 44 and the yellow one might be 46. Does that make sense? Or if I tell you one of them's or the EBC angle is 100, maybe the green one's 49 and the yellow one's 51, right? Your eyes aren't precise enough to determine that 1 to 2 angle difference, okay? Now, they look very close to one, they look very similar in size, but we would not say that these angles are congruent because there's no information leading me to that, meaning that there's nothing like that being drawn in the angle. Does that make sense? That is notation that tells me, yes, now I know that those two angles are congruent. Okay? Does that make sense? Okay. So from a picture, if my picture looks like that, no, absolutely not. I cannot say they're congruent. Even though they look like it, I can't say it. If they give me that stuff, yes, they're congruent. Okay? There might be times where they do this. And they say that, well, let me ask this way. It'd be easier to talk about this question. Let's go say, is AB, is that segment congruent to segment BC? Does it look like B is halfway in between? Okay, does everybody see AB and BC? Okay. Does B look like it's halfway in between A and C? It does. It looks halfway in between to me. Okay. But let's say AC is 10, maybe is 5.01, and BC's length is 4.99. Would your eyes be able to tell that difference? No, your eyes probably won't even be able to tell the difference in 1/8 of an inch, or maybe even, from your seats, maybe even 1/4 of an inch. Okay. So we can't make that argument that those are congruent until somehow in the picture they tell me that. Does that make sense? Okay. Now, there will be times where they do this. In the directions, it will say B is a